Okay, so welcome everybody from all over the world for coming to this presentation at this historical moment. My name is Yeonji Jung, and I'm a PhD student at New York University, and Dr. Elisa Friend-Wise is also being here at this room. Hi, Elisa.
Hi, everyone. Thanks for coming.
Okay, and today we will share our exciting work on understanding and supporting student reflection in health professions education. So now let's get started. So when you started this study, we questioned ourselves, what would be a key factor that we can understand for health professions students? And is this something that students can gradually develop with appropriate support? So as you can see right now, health professions are situated in a very demanding work context. They also have to learn the constantly developing knowledge base. In this situation, reflective practice can be a way for health professionals to continuously monitor their complex tasks and also competently address them. So these efforts can support them in providing a better quality of care. So reflective writing is widely used in health professions education to help students practice reflective skills. So by reflecting, students can keep aware of how they conduct their professional practices and also identify the needs for their own professional development. So through this process, students can get a chance to develop their competency to work as a professional in practice. So in this context, we can think about the question, in what ways can we understand how they are reflecting? The previous studies in health professions education usually focus on how well or deeply students reflect on their academic life. So for example, do students monitor what they experienced, or do they describe what they learned from these experiences? Such unidimensional approach can be efficient to quickly identify the overall quality of reflection. However, this approach can be problematic due to its one-size-fits-all conceptualization. So alternatively, we can think about multiple components which are important for students to describe in their reflections. So for example, scholars found that cognitive components such as descriptive thinking or analytical thinking and evaluative judgment are important elements that successful students need to describe in their reflections. But also affective and social components such as feeling and perspective are important to think about when students reflect. Especially thoughts about taking care of others, such as patients, is a key concept that health professions students need to develop throughout the program. So outcome, which is defined as lessons learned or future intentions, is also important regarding students' metacognitive skills. So such multidimensional approach is comprehensive to identify in which parts in reflections are inadequate or enough. However, this approach can be very complicated to use as a criteria for assessing reflection, especially at scale. So compounding the issue is that manual assessment is time-consuming. And for that, there has been a great interest in developing automated reflection assessment to reduce the burden on instructors and provide support to students. However, little is known about automated reflection assessment in health professions education. Rather, most of studies were situated at the general domain of higher education. So we address these issues through the development of multidimensional automated assessment for health professions reflection. So first, we attempt to identify which reflection elements can be reliably predicted using linguistic features. For example, can we well predict the presence of description in a reflection? How about the presence of feelings? As a feature, we calculated the degree to which various categories of words are used in individual reflections. Then we also attempt to identify whether the depth of reflections can be reliably predicted by linguistic features. Finally, we assume that the presence of 6 elements may relate to the level of depth. Thus, we attempt to investigate whether the depth can be also reliably predicted from the reflection elements. So for participants in this study, so the reflection context was a 4-year predoctorate dental program in the United States. The participants are over 378 students in a single graduating year during their 4 years of schooling. Then how were they prompted to reflect? So students were required to respond to various reflective prompts throughout their program in the online portfolio system. So this system was designed for the students to practice self-assessment as part of their professional development. So students should complete individual reflections at the start and end of every academic year. So this study focused on a general type of reflections called statement prompt. So this prompt asked general thoughts about personal or academic or professional progress. So to start our analysis, we extracted 7,510 statements in this general prompt made by all 378 students. Then we cleaned missing values, duplicated reflections, and outliers. Then we used stratified random sampling to extract a subset of 1,500 statements. This is 1/3 of the total corpus made by 369 students. So to establish ground truth, we first manually annotated 1,500 statements with the 6 elements and depth coding schemes based on the theoretical framework. So we confirmed that inter-rater reliability was stable at the CROMBOS alpha above 0.7 across a series of coding training and 7 rounds of content analysis. For example, our unit of analysis is the entire text of a reflection, since we found that elements and depth are often present across multiple sentences. So if a student describes their feeling like nervous or confident, we checked it as that feeling was present in a reflection. So then we started computational assessment. First, we extracted features by using a predefined dictionary called LIWC. We extracted 76 of 93 features designed to capture people's social and psychological states. So this is an example of how LIWC works. So this software measures the degree to which various categories of words are used in a reflection over the total word count. So then we started training the models. So for elements, we trained the models in 2 different ways. One, we built 6 binary classifiers to predict the presence of each element in reflections. In this process, we use random forest method for 2 reasons. One, we checked that random forest classifiers outperformed over the other classifiers across all elements. 2, random forest method can support us in a better interpretation of what features are important for their classification task. Then we trained the individual classifiers with optimized hyperparameters using tenfold cross-validation. Another model we built is a multi-label classifier which assigns a reflection to a set of target labels at the same time. So in this case, target labels are individual elements. So we assumed that each label presents a different classification task, but the tasks are conceptually related. So we use the classifier chains method to build this model. So classifier chains method transforms a multi-label task into multiple binary tasks, so 1 task for each label, so that each binary model is trained to predict the relevance of one of these labels. Then this method forms a classifier chain across these binary tasks. So then we trained this model. So performance was measured by the macro averaging method. So this takes the average metrics for each label classification over the total number of labels. Finally, after model training, we tested individual classifiers to the holdout test set. So then for the individual classifiers, we assessed feature importance using the mean decrease Gini index. So this is an effective measure of how important the feature is for estimating the presence of the target outcome across all the trees that make up the forest. So the multi-label classifier was then tested on the holdout data. And feature importance for this classifier was measured using average chi-squared estimates of each feature across all the elements. So then for the depth, we trained 2 different models using different features. So first, we use linguistic features extracted from LIWC software to predict the level of depth. And this is research question 2. And second, we use the manually coded values of reflection elements as features to predict the depth. We assumed that a set of reflection elements relate to the depth and can predict it. So we used a random forest for both classifiers and trained each classifier with optimized hyperparameters. So the linguistic classifier was tested to the holdout test set. However, the depth classifier using presence of elements was tested on 2 holdout test sets. So first, tested to the values of elements coded manually, and also we are interested in whether this model worked to the values of elements predicted by the 6 single label classifiers. So for both classifiers, we assessed feature importance using MGG scores as I explained. So what did you find, and can you understand how students reflect? So first, we found that there are variations of presence across the elements. In general, students were highly likely to include outcome in most of their reflections. As you can see, the outcome reflections far outweigh no outcome reflections. So if we train a binary model without fixing this problem, the model will be biased a lot. So we addressed this class imbalance issue by oversampling the minority class through a small T method. So we created synthetic data instances to increase the percentage of minority cases from 7% to 34 total sample here. And we also found that students included description, perspective, and evaluation in the majority of their reflections. However, analysis and feeling did not occur frequently in reflections. So based on this understanding, we further questioned, can you reliably predict presence of reflection elements? And then which elements can be well predicted using linguistic features? So first, we found that description and evaluation classifiers showed the best performance. They individually showed substantial kappa values above 0.65. And analysis, feeling, perspective, and outcome also showed high accuracy above 0.75 and moderate kappa values above 0.50. However, outcome classifier raised the issue again. The outcome classifier showed a very good performance in cross-validation, but it showed a dramatic decrease here in its performance on the test set. So this might relate to the problems with overfitting that could come from our resampling of outcome class. So while some models have room for improvement, we could conclude that linguistic modeling can be useful to detect the presence of most of the reflection elements. So then, what specific features are important to predict these elements respectively? So since we use random forest method to build these classifiers, we could compute MDG scores. The number of these scores indicates how important each feature is for predicting each element. So interestingly, we found that description, analysis, and evaluation showed a similar pattern. So all 3 classifiers heavily depended on a few similar set of features, such as the use of past-oriented words and expression of personal voice. However, description and evaluation showed more similarity in feature importance, next strongly predicted by first-person pronouns, and here feature-oriented words. On the contrary, analysis depended more on causal and insight words. So this suggests that there may be certain conceptual connections between description and evaluation more, and there is a need for a better classification distinction with analysis. So the feeling classifier also depended on similar features such as past-oriented words, but also predicted by affective features such as words related to feeling, anxiety, and positive emotions, or social factors such as clout. Perspective was highly predicted by the use of third-person pronouns, an expression of personal voice, positive emotion, or time and work, which may relate to one's effort to take account of others. So this unique feature profile of perspective may indicate its important conceptual distinction from the other elements. For outcome classifier, the most important feature was the use of first-person pronoun and social relations such as cloud, affiliation, we, and you. So put together, we found that there are both conceptual similarity and distinction across elements. So these findings made us rethink about the relationships between the elements. Some features regarded as important are similar with each other. So do students include multiple elements in their reflections at the same time? So as a first step, we checked chi-square values across the elements. We found that, not surprisingly, description, analysis, and evaluation all had high associations with each other. On the contrary, perspective and outcome had low association with each other. So such findings suggest the need to consider the relationships between elements when developing classifiers. Thus, rather than building separate classifiers without consideration of their relationships, we decided to develop a multi-label classifier which considers their relationships as relevant to their classification task. However, we found that this classifier did not outperform the 6 single-label classifiers. Also, the model depended heavily on a few features which were commonly observed as important features in single-label classifiers. So such similarities may suggest the need to look at what features can well capture the differences between elements. So after we understood how students reflect in various ways, we also tried to answer the question. So how well do dental students reflect? First, we checked the level of depth in reflections. Not surprisingly, students reflected in a shallow level the most, followed by no level. Also, we checked associations between the elements and the depth. So surprisingly, a depth was highly associated with the aforementioned clusters: description, analysis, and evaluation. However, depth was not that much associated with the perspective and outcome. So from this finding, we could assume that the presence of reflection elements can be useful for predicting the depth. So based on this understanding, we further questioned, can we reliably predict the level of reflection depth? As I described, we trained 2 different models using different features. 1, using linguistic features. 2, using coded values of elements. Then this elements model was tested in 2 different sets. 1, the data with coded elements, and 2, the data with predicted elements by 6 single-label classifiers. So which model could perform well? So we found that the model with the coded elements produced improved performance over the other models. Specifically, in this model, there was no confusion between no and deep reflections, but deep reflections were commonly misclassified as shallow reflections. The depth model with linguistic features also performed well, showing high accuracy of around 0.8 and reliable kappa values. Similarly, there was no confusion between no and deep reflections. However, the model with the predicted elements showed reduced reliability compared to the others. So despite some variations across models, we confirmed that we could assess reflection depth. So then what specific features are important to predict the level of depth? So similar to the majority of reflection elements, a few linguistic features played an important role in model performance. So in line with the description, analysis, and evaluation, the most important features were related to the use of past-oriented words and word count and expression of personal voice. To better understand the difference to better understand the differences across levels, we also computed mean of values of each feature over reflections. So both deep and shallow reflections contained more use of past-oriented words and longer word count. So this finding aligns with the coding schemes that we defined. Deep reflection was defined as a reflection which shows implications drawn from what students experienced. No reflections had a relatively high use of feature-oriented words and self-discrepancy words. In addition to linguistic features, what elements are important for predicting the depth? The depth classifier built on reflection elements heavily depended on description. So description serves almost as a binary divider between deep or shallow and no level. Also, analysis and evaluation was more associated with deep reflections than shallow reflections. So this echoes the literature that the highest level of depth was more associated with causal and perceptual words. So from our finding, we learned three key ideas. First, this finding confirms that the literature that linguistic features can be useful to detect the presence of reflection elements as well as the level of depth in students' reflections. Second, we found that some elements showed similar characteristics regarding their presence rate, association with other elements, and feature importance. So for example, cognitive elements such as description, analysis, and evaluation had a lot in common. So these cognitive elements even relate to the prediction of depth. So the depth model built from linguistic features showed a similar profile of feature importance with these cognitive elements. So also the depth model built from elements heavily depended on these cognitive elements. So we assume that the global reflection quality may be evaluated based on more on cognitive aspects than affective and social elements. So this issue raises an important question about what really constitutes the quality of reflection. So based on the findings, we would like to articulate two key implications for research. First, there is a need to examine the conceptual distinction between cognitive elements and the others. We can decide either how to better distinguish them, like manually or computationally, or collapse them. So development and validation of such a measure is an area for future work. And second, we also need to reconsider how reflection quality is defined. This study conceptualized that reflection elements are important for the global evaluation of reflection depth. However, we found that depth was heavily related to cognitive elements, not the others. So to address this issue, a composite measure of reflection elements could offer a better indicator of overall reflection quality. So put together, we argue that such reconsiderations can be an example of how learning analytics work can not only draw on the theory, but also contribute back to the theory. So then how might we integrate what we found in this study into the process of students' reflective writing? So in what ways can we provide feedback to support students' reflective practice? So right now, we are in the very early stage of feedback design in partnership with College of Dentistry. So one idea is to use the models to inform instructors of students' reflection progress. Instructors can use this information when they advise students. So this can be done by either showing a profile of overall reflection quality or a specific part of their reflections, which is missing a particular element. Also, we can provide this information for students as a diagnostic profile to monitor their reflective practice. So taken a step further, the online reflection system can incorporate filtering or annotation tools for self-assessment. So this self-assessment tool can give students the opportunity to compare the analytic values with their self-assessed ones. So we can use this students' perspective for reconsidering what measures of reflection should capture. So now we are extending this study by considering temporal aspect of reflection. So for example, can you understand whether and how differently students reflect across academic years? Then how can you consider this change when testing the models we developed? So if you are interested in new findings about temporal reflection or more information about this study, please join us after this session at 11:30 a.m. before the keynote. So we are holding a chatting room at bit.ly/learn-lag20. All right, thank you so much for listening to this talk, and we are very happy to answer any questions you have.